Welcome to class on structure of atom, and today's class is class number 22, higher secondary first year. It is the topic in chemistry, and today I will specifically discuss about the shape of orbitals. And many of you have a poor knowledge of the shape of orbitals. So today I will start or discuss about the shape of orbital. Minutely focus on the class so that you can have profound knowledge on shape of orbitals. So before the shape of orbital, let me first explain some of the important terms which you will very often come in across during explanation or solving out the problem in entrance exams, also in your class exam. So first of all, node. You will very often find the term node. What is node? Node is nothing but a space, a three-dimensional space, where the probability of finding the electron is almost nil. Space, area, now it is the region or the space or the area around which you will find the possibility of finding electron is almost nil. It is node. Next part, the term is radial node. It is again node. Node means probability of finding the electron is almost nil. It is the region of the space or the area, but there a term radial means from the center around the circular way, means it is a space in a circular manner. It is a circular space. Circular space where the probability of finding the electron is almost nil. Now, next two terms I have written in a closed way, and many of you may not have the idea that angular node and nodal plane both are of same. Both the term will explain the same meaning. Angular node or nodal plane means it is not a circular space, it is a plane xy. In geometry you have got xy, yz, zx. So there is a plane where there is probability of finding electron is almost nil. That's why it is called angular node or nodal plane. Now, before coming to the actual point of the shape of the orbital, now let me tell you something. Very simple mathematical formulas are radial nodes. It is n minus l minus 1, and angular node or nodal plane is nothing but l, and total node is equal to radial node plus angular node or nodal node. If you add up these two, you will get total node. So radial node means principal quantum number, l means azimuthal quantum numbers, and angular node is equal to simple azimuthal quantum number. If you add up these two, you will get total node. Sometimes in the exam you are asked to find out the number of angular node, number of plane, nodal plane, or number of radial node, or total number of nodes. If you have the knowledge on the formula of these things, you can very easily find out the number of radial node, angular node, nodal planes, and total nodes. Now let me come to the main point that I have written in the topic itself is the shape of the orbital. Let us subshells. Let us consider the subshells S. So for S, you know it in by previous class. I have already explained that for S orbital, L is equal to 0, and for L is equal to 0, the value of M is equal to minus L2 plus L, means M is equal to minus L2 plus L. That is, if you put the value of L here, you will get the value of M is equal to 1. And you have already I have already explained that L is equal to azimuthal quantum number and M is equal to magnetic quantum number. And magnetic quantum number is this quantum number which gives the orientation of the orbital in the three-dimensional space in which way it is oriented. So from this value, for S subshell, L is equal to 0, M is equal to 0. That means that M is equal to 0 means orientation is 0. Means S orbital doesn't have any orientation in the space. Hence, it is nothing but spherical in shape. It is spherical in shape. And the probability of finding, if it is center, except center, the probability of finding electron is same in all the equal portion, all the same equidistance from the center, and gives rise to a figure like sphere. Now let us come to the p orbital. For p, L is equal to 1. For L is equal to 1, M is equal to minus L2 plus L, means minus 1 to plus 1, means minus 1, 0 and 1. That is, we have got the value of M, three values of M here clearly indicates that the orientation M related to orientation of p orbital is in three types. That is, S orbital, p orbital are of three types. One is if it is X, if it is Y, and if it is Z. So it is in px orbital. And another one is orientation is if it is Y, X, and if it is Z, Z. And last type is so along with the value of the magnetic quantum number, we have got the value of with the value of L, we have got the value of M is equal to minus 1, 0 to 1, means M has three values, and with the three values we have understood that it has three orientation in the space. And first orientation is that it is in dumbbell shape, and that this dumbbell shape is oriented in the X orbital, and the dumbbell shape is oriented in the Y orbital, and dumbbell shape is oriented in the Z orbital. It has three possibilities, and it has three different type of shapes. One is px, py, pz. Now if you come to D, so for D, L is equal to 2, it is known to you all. So M will be equal to minus 2 to plus 2, means minus 2 minus 1, 0 plus 1 plus 2, means in total the value of M equal to 5 values. That means d orbital is double dumbbell in shape, and it has 5 different type of orientation. That's why double dumbbell shape of d orbital may be represented as So, in a very precise manner, let me explain the shape of the d orbital. It is a bit difficult and typical. You must know the art of drawing, otherwise you can't do it, because there is a plane, there is x, y, y, z, and z x plane are there. So, out of this plane means one plane is x, other plane is y, and other plane is z in this way. So, it is a very complicated way. X, y, y, z, and z x plane is there. Am I right? So, without three-dimensional things along in my hand, I can't make you to understand what actually it is. But for drawing, let me explain. If it is x, y, and z, so you assume this is x, this is y, and this is z. X, y side by side. So x and y, in x, y, the two dumbbell shapes are in x, y direction. That's why dxy. Other is dy, z. When I have drawn y, z, I have taken y and z side by side and have assumed it as z, y, z, yz plane. And when I have assumed zx, I have taken z and x side by side and y in perpendicular of these two. So this is zx. It seems to be alike in all the cases, but when you will draw practically with three-dimensional manner, it is a bit different only in terms of its plane. So next one is dx square minus y square, and it is a bit different where x and y have drawn side by side. X square y square means along x axis. Nowhere there is along, the lobes are along, it is in the plane in between, and here it is along x and along y, means x square minus y square, and here it is z square. It is again different type and peculiar, where there is, it is z axis. Along z axis there are two lobes, and others it cannot be shown, and it is in a circular manner, and this is a funnel shape structure. It is called conical node. I will explain a bit later. It is a node. There is no nodal plane is there. There is a conical node in dx square, or just you keep it in your mind. There is no nodal plane here, d plane. In bit by bit, I will explain node, antinode, angular node, nodal planes, and total nodes in each and every orbital. So I have in details shown you the s orbital, shape of s orbital, px, py, pz, and dxy, yz, z square, s square, y square, and g z square. Now the things which very often asked in the exam is, let us assume 1s, and you are asked first question, radial node. For 1s, here n is equal to 1, and if you are asked, are there nodal plane or angular nodes or total node or radial nodes? Let us check whether there is any radial node. In symbolically, I am writing Rn, radial node. Radial node means n minus L minus 1, where there is n is equal to 1, and for s orbital it is equal to 0 minus 1 equal to 0. There is no radial node in s orbital, 1s orbital. So come to the second point, angular node or nodal plane. If you tell here nodal plane, so the formula of nodal plane is equal to L. Again here for s orbital, L is equal to 0, means it doesn't have any nodal plane. So radial node is there, no nodal plane is there. So how much nodal node? Total node is n minus 1, means n minus 1. If you tell total node, the value is n minus 1 is equal to 1 minus 1 equal to 0, means 1s orbital does not have any 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 node. Radial node no, angular node no, nodal plane no, total node nothing. So now let us change this. Let us write it to twice s orbital, means 1s shape of the 1s orbital is like this, and it is in this way. If you draw the figure, it is like this. 1s, there is no node, there is no space inside the sphere where there is any probability of finding electron is almost nil. Everywhere you will get some probability of finding the electron, maybe less, maybe more. But if you assume twice s, what is radial node? So the formula of radial node is equal to n minus l minus 1. N minus l minus 1 means it is 2, and the value of l for s orbital equal to 1 minus 1 is equal to 1, means twice s orbital has one radial node. Now let us assume whether it has an angular node. Yes, nodal plane or angular nodes are same thing. It is the value of l, where l is equal to 0. Again, it doesn't have any angular node. So total node 1 plus 0 is equal to 1, or n minus 1 means 2 minus 1 is equal to 1. So we have seen in twice s orbital, it looks like in this way. Means there is somewhere in a spherical shape, a space, circular space around the center or the nucleus, where there is no possibility or almost nil possibility of finding electron density or electron probability of finding electron, and that circular one is called radial node, and there is one radial node. This is the shape of twice s orbital with one radial node. Now come to the thrice s. For thrice s, n is equal to 3, and radial node is equal to 3 minus 0 minus 1 is equal to 2, and nodal plane again for l is equal to 0. This s orbital, there is no radial nodal plane or angular node, and total node is equal to 3 minus 1 is equal to 2. That is, it has two radial node and no angular node or nodal plane, and there is total node is equal to 2. Now how will you draw this figure? This figure is very simple. Just you draw in this way. So you see here in the figure, thrice s orbital, you see there is one circular space, that is radial node, where there is no possibility of finding the electron, and there is another radial node where there is no probability of finding electron. So there are two radial nodes in thrice s orbital. So I have shown you 1s orbital, 2s orbital, and thrice s orbital along with radial node or nodal plane or total node. Now let me come thrice p. Come to thrice p. So here n is equal to 3 and l is equal to 1. Let us now check radial node. What is radial node? Radial node is equal to n minus l minus 1. 3 minus 1 minus 1 is equal to 1. What is angular or nodal plane? Angular or nodal plane is equal to l. L is equal to how much? 1. Just for first time we have got there is a nodal plane in Classby orbital. Now what is total node? Total node is equal to n minus 1 means thrice, n minus 1 means thrice minus 1 is equal to 2. 1 plus 1 means 2. There are total node 2. Now how will explain that there is one radial node, sorry, one radial node and one angular node in p orbital. So let us draw one p orbital like this. It is px. If you assume this x and this is y and this is z, so you will find this is x orbital, dumbbell shapes px orbital, where there is one radial node, means somewhere in a circular manner in this way. Here this side or this side there is a space where there is no possibility of finding electron, and that is the signal of one radial node in px or py and pz. In the same way you will find there is a circular node is there and radial node is there. Now what is angular plane? What is nodal plane? How will you tell about the nodal plane? So you see the trick is here, one trick you should apply. This is px. Now what is other two? There is x, y and z. Along with this you get xy, yz, zx axis, xy axis, yz axis, zs axis. It is a three-dimensional axis, sorry, plane. With three axes you will get three plane, xy, yz, zx. Now there is distinctly, I have shown you a bit earlier, there is one nodal plane where there is no possibility, there is a plane where there is no possibility of finding electron. That means which plane it doesn't have any electron, in which plane there is no possibility of finding electron. That plane is just to subtract x from xyz. What you are getting is xz or zx, means zx is a nodal plane or xz or zx is a nodal plane where it is a nodal plane where there is no possibility of finding electron. Now if you take the example of this, if you take the example of this, means if you assume it y, x and this as z, that is py. Now if you are asked in the same way, you will get there is a radial node is there somewhere in this way, and there is an nodal plane. Which nodal plane? It doesn't have any electron possibility of finding the electron density. You subtract y from xyz, xyz. So you are getting, I'm mistaken, if you subtract x, so from xyz you are getting yz here. Yz is the nodal plane where there is no possibility. Here y, you subtract y, you are getting zx. Zx is a nodal plane where there is no possibility. Likewise, if it is in z axis, it will be pz. So you would subtract z from this. xy is a nodal plane. Am I right? So in case of thrice p, you have got one radial plane, one radial node, and one nodal plane, and this which will be this nodal plane I have explained. With the help of trick you can find out. Now a bit difficulties with z axis, with d orbital. So if you assume thrice d, from thrice d n is equal to 3 and for l is equal to 2, it is d orbital. It is known to you all. So for radial node, if you find for radial node, this is equal to n minus 1, n minus l minus 1, means you are getting no radial node in thrice d orbital. Now come to the nodal plane. What is nodal plane? Nodal plane equal to L. What is L? L is equal to 2. That is, in thrice d orbital, always there are 5 d orbital, x, y, y, z, zx, and x square minus y square and z square. In all these orbital, you will find 2 nodal planes. No radial planes are there. 2 nodal planes, and out of except one, I will show you. There in somewhere you will get in dx square, dz square, you will not get any nodal plane. But out of this you will get 2 nodal plane. Now how will calculate these 2 nodal plane? Say I will show only one, and I will you yourself can draw yourself, and you can find out if it is x and if it is y and if you assume it z. So this is x and y, am I right? So what are the way of getting nodal plane? So radial node is 0 and nodal plane is 2. Now what is, say it is dxy, am I right? So out of dxy you are to find out, two nodal plane where there is no possibility of finding electron, or there is probability of electron density is almost nil. And what is this two nodal plane? So out of these two, xy, always this is xy and z, you subtract xy, what you get? You are getting z. With the z you multiply these two, with the z you multiply these two, you are getting zx and yz. These are the two nodal plane where there is no possibility of finding electron. So if it is dxy, it is yz. If it is yz, so from xyz you subtract yz, you are getting x, and with this x you multiply both these two. Same way you apply. If it is xy, so which you remain, the left one is z. With this z you multiply this zx and zy. These are two plane. If it is dyz, which remains is x. So you multiply with remaining x with these two, xy and zx are the two nodal plane in dx square y square. Likewise you do. But the problem is, with this question very often asked in the exam, is it d orbital d z square. So in dz square, you will get a funnel shape structures, and here there is no possibility of finding outside the sphere, outside this shape. It is conical, plane, no nodal plane is there. It makes a cone out of this one, and out of this cone shape you will get no electron density, and inside it you will get, but outside of the surface of this cone, that is conical plane, you will not get any possibility of finding any electron in this shape, and hence it doesn't have any nodal plane. But this plane which it has is dz square, is conical plane where there is no possibility of finding electron. This is all about the shapes and nodal plane, nodes, total nodes and radial nodes of s, p and d orbital. Let me come to the very simple and general, each and everybody of you know, and I don't find it much important to explain here, Pauli's exclusion principle. Pauli's exclusion principle. It is very simple, nothing to explain in details, and lots of things are there which I will explain when I will give you the set of the question for entrance exam. So basic concept is that Pauli states that it is no two electron in an atom can have same sets of 4 quantum number equally. Have got the 4 quantum number quantum sets: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. So in an orbit, if you get the 2 electrons are there in the orbit, and if one spins in this direction, other spins in the opposite direction, the spin there is opposite spins. Am I right? They are moving in this way, in opposite spin. One up, other down means one clockwise, other anti-clockwise. In this way, electrons are revolving in the orbitals. So Pauli states that not 2 electron in an atom. If there is 2 electron in an atom in the orbitals, so what's happened? These 2 electrons have 4 sets of quantum number. Say if it is in 1s orbital, if 2 electrons are 1s orbital, 1 electron and 1 electron, that 1s2 are in orbiting in the 1s orbital. Now for 1s orbital, n is equal to 0. For n is equal to 1. So L is equal to 0, m is equal to 0, s is equal to plus half. And for another 1 electron out of 2, you are getting again n is equal to 1 because this is in 1s orbital, and L is equal to 0 because it is s orbital, and m is equal to 0 because minus 0 to plus 0 equal to 0, n is equal to minus 1. From here it is seen that it has at least three sets of quantum numbers equal, but at least there is a difference in the quantum value in spin. So it cannot have 4 sets exactly equal. It cannot be equal in all aspects. 4 sets should not, or 4 sets of quantum numbers should not be equal in all sets. Hence, Pauli states in this way: no 2 electron in an atom can have 4 sets of quantum number equal. Now, simple and very light explanation is on Hund's rule. Hund's rule. Hund's rule, again, it is very simple. Very simple. Very simple explanation. You very often you can do in various types of problems. Electron occupy the orbital singly fast and then pairing starts. Very simple. Let me explain. Say in P you are getting 3 block in block diagram. So if I write in Px, if you get Py, it is Pz. Say there is 5 electron in P. In P, in totality it is P, am I right? So P is subdivided into Px, Py and Pz. So you are to populate 5 electron in it. So what Hund's says is that each block should get electron singly fast. Each block, electron occupy each block singly fast. And if remains, still 2 remains, then pairing starts. It is in this way. If say if there is 3 electron, if you want to populate this 3 electron in it, so it will never be in this way, no, but it should be electron first you give 1 each, and if any remains then you put up. If 3 electrons are there, it should not occupy in this way, but it should occupy in this way. This is the statement of Hund's rule, nothing else. Sometimes in your class exam you are asked to write the electronic configuration of nitrogen or anything. Say nitrogen atomic number is equal to 7 in terms of Hund's rule. So you write 1s, 2s, twice p, 2, 2 and 3. Am I right? So if you write in this way, it will not be in accordance with Hund's rule. So if you are asked in this way, you are write 2pxy, 2py and 2pz, and you give 1 electron in each. This is in accordance with the rule of Hund's rule. If you ask to write the electron configuration, you should write Hund's rule in this way. Very simple, nothing else, nothing more to explain. And next and last part of this today's topic is above principle. So sometimes it appears that it is a name, but it is nothing, but it is not a name, but it is nothing, but it is not a name, but it is a word which explains the building up of electron. Electron occupies in the orbital, electron filled up or electron filled up or add up in the orbital in order of again very simple about according to this principle, electrons fills up in the orbital in the order of in increasing energy starting from the lowest energy level of orbital, means from lowest energy level to the highest energy level the occupation of electron starts. First you will occupy this, again another 2, then it goes to this one, again 2, then next up to 6, then it goes to this one, means it is in accordance of increasing energy of orbital. Electron starts filling up the orbital from lower energy to the higher energy, and in this way there is a n plus n rule given along with this rule, and this rule is a very important rule for prediction of higher energy if there is any confusion regarding n plus n rule. Say one is 4s and other is thrice p, and for 4s n is equal to 4 and here l is equal to 0, here n is equal to 3 and l is equal to 1. Am I right? So if you write n plus l is equal to here 4 and here n plus l is equal to 4, now there is a confusion which one has same energy, so higher energy, or which one of the orbital has the lower energy. According to this rule, the n plus n value, which one has the more n plus n value will have the more energy. But if the two orbital have same n plus n value, then the more energy will be decided by the greater value of n, principal quantum number. Here in this case both the orbital has n plus n value is equal to 4 and 4, but so nothing is both the term values are the same, no one is greater than other or less than other. So if greater value has n plus and greater value has greater energy, so since the both has the same energy, same value, so we'll decide which one has the more energy will be decided by the greater value of principal quantum number. So this has more energy than this according to n plus n rule. So last talk I will show you one of the very simple, very often I tell this rule to write the electronic configuration in this way. So how to draw the electronic configuration 1s, 2s, twice p? Just you say, see, you give 1, 2, 3, 4, 5, 6, 7, 8. So one things you keep gap 1, gap 2, gap 3, gap this. Now the second technique is that, so 1 and 2 you don't touch this. Before 1 there is no number 0, there is no orbital like 0, and before 2 there is 1, before 2 there is 1, preceding number is 1. So 1 does not repeat, that's why we will not touch this one. So come to this one. So before 3 there is 2 and before 4 there is 3. So up to 1 number you go above in this way. Now come to these two. You have gone 1 value. Here you go up to 2 value. 5, 4, 3, 6, 5, 4. Now here 3 value up 2 value. Here 1 value up. Here 2 value up. Here 3 value up. 7, 6, 5, 4, 8, 7, 6, 5. Now the below line all will be S. All will be S. Am I right? And now you give arrow in this way, start in this way. This is all about, you can write about 118 element electronic configuration 1s. You go on writing 1s twice s. Sorry, one thing I have forgotten. It is 1s twice s, then Sn. What is this? Now this is S, Sp, Sp. These two Sp, Spd, Spd. These two Spd. This is Sp, this is Spd, and this is Spd. F. So this is S, Sp, Spd, Spdf. Am I right? So you write S, P, P, D, Sp, D, F, Sp, D, F. Now you yourself can write 1s, twice s, twice p, thrice s, thrice p, 4s, thrice d, 4p, 5s, 4d, 5p, 6s, gone. You can write 1s, twice s, twice p, thrice s, thrice p, 4s, thrice d as up to 118 atomic electronic number. So this is all about the building up of the electronic configuration in accordance with the principle of above. Now there is some problem or exceptions in writing the electronic configurations of chromium 24 and copper 29 here. So as per this atomic number, if you fill up the orbital, you know the maximum value of S is equal to 2, P is equal to 6, and D is equal to 10. Am I right? If you go on writing in this way, you will write the electronic configuration in this way, but all will be the same. But the last there will be 4s, not 2, it will be 1, and 3d it will be 5, and here also in the last, here this will be 4s1 and 3d 10, and also a lots of other elements in there. In gadolinium 64 the same changes there. In silver 47, I think again you will get the same thing. You have to do in this way. So up to 30 atomic number you will get these two exception. Now how to explain these two exceptions of these two electronic configuration, where S doesn't have 2, S is 1 and D5. This is one of the factors that just I am telling orally. You just keep it in your mind. That is the P or D orbital which are completely half filled or completely filled, means if it is P orbital, it is in 3 part, and if it is D, there is 5 part, say it is 5, so that 5 in D should be like 1 2 3 4 5, not in this way. If it would have been D4 as earlier, if S2 D4, then it would have been in this way. So it is told that there is a reason also I'll explain, that completely, this is called completely half filled. This completely half filled or completely filled, either P or D orbital, if it is completely filled or completely half filled, it is more stable or less energy. So completely filled or completely half filled orbital are more stable, less energy than any type of arrangement. So if it is 4 electron, if it is 5 electron in this case, the stability of this completely half filled orbital is more than any other type of arrangement. The stability of completely half filled or completely filled orbitals are more than any type of other arrangement. That's why N4 S1 D5, to get the more stability of the electron in the state having less energy, the arrangement has changed in this way. So likewise this, if it is 9, if it is 9 in d orbital, so if it is 9 in d orbital, so 1 2 3 5 6 7 8 9, it is this configuration of 9 electron. And if it is 10, then there 1 electron will come. So whenever 1 electron will come, it is completely filled. So as per rule, the completely filled or completely half filled arrangement of the electron in the orbital has less energy and more stability. That's why D9 configuration has less stability and it becomes 4s1 and D10. This is the simple reason. Hope you have followed the class with utmost interest. Thanks a lot for watching the class. In the next class, I will come with another structure, especially chemical bonding, which is a very big one. Thanks for watching the class, and don't forget to subscribe the class.